let's look into why density is important, what characteristics it has, and also the formula. So when we think about what is heavier, sometimes we think, oh, this is pretty heavy, or maybe like a very small piece of like, a block or something is heavy. So you think, why is it heavy? Why is this heavier? Why does this feel heavy? And sometimes something very big in a big box feels very light. So let's take this scenario. What is heavier, a pound of feathers or a pound of lead? Most of us always think, okay, well, a pound of lead, because you think lead is pretty heavy. Lead is a metal, things like that. So why does it feel heavy? Well, the answer is actually that they're both the same. They're the same mass technically, because if you think about it, a pound of feathers is the same as a pound of lead, no matter what kind of material it is. However, for a pound of feathers, in order for feathers to add up to a pound, you need a lot more of it. So obviously you need a lot more feathers. So what happens here is that lead is what we call a much more density, okay? Because it takes up very little space for the mass that it has. So lead has what we call a greater mass per unit volume, so that's why it has greater density than a feather. So density, what is density? Density is basically taking mass into volume into consideration. So basically, how heavy is something for the size that it occupies? Let's take a look. Like I said, lead, for example. Lead has high density because even though it's it can be a very small block of lead, it's still very heavy due to the fact that it takes up very little volume. However, air has very low density due to the fact that we can take a very large sample, that's why air can float, and it still doesn't feel heavy. So density has these properties. However, density also has a formula to it. So density is equal to the mass divided by the volume. And for density, we have two units. Normally, density is in grams per liter or grams per milliliter. And the mass is in grams and the volume is in liters or milliliters. By the way, like I said, it says down here, don't try to cancel out the units for density. It's a 2-unit part, so it's always grams per liter or grams per milliliter. That slash means sorry. So just make sure you don't try to cancel that out. So let's take a look at this problem. It says, what is the density of a sample with a mass of 2.50 grams and a volume of 1.7 milliliters? Well, we know that density is equal to mass divided by volume. So we have to figure out what is the mass, what is the volume, because we want to solve for density. Remember, I said mass is in grams. The volume is in liters or milliliters. It will vary. Sometimes it all depends on what the problem gives you, but it can be either or, all right? And then density is always in grams per liter or grams per milliliter. It all depends on what the volume unit is in. So if mass is in grams, which of these two numbers has grams as a unit? And we can automatically see it's 2.50 grams. So my density is equal to 2.50 grams, all right? And what is my volume? My volume automatically is 1.7 milliliters, since that's one of the volume units. And if you do this in your calculator, you get 2.50 divided by 1.7. You get this number. Now, according to significant figures, this is a division problem. And again, yes, significant figures count here as well. We have 3 significant figures here. We have 2 significant figures here. So our final answer can only have 2 significant figures. So that means it's 1.4. But before I cut it off, I have to make sure that the 4 rounds up or stays the same. And technically it rounds up due to the 7 being next to it. So your final answer for density is equal to 1.5. And then you take both units, grams per milliliters. All right, so we did a problem with solving for density. Now let's do a problem where solving for mass. So the question asks, what is the mass of a 2.34 milliliter sample with a density of 2.78 grams per milliliter? Remember, density formula. is density is equal to mass divided by volume. Mass is always in grams, volume is always in liters or milliliters, and density is always in grams per milliliter or grams per liter, depending on the volume unit. So, again, always look for these units next to numbers. That way you know where exactly your numbers have to be placed. For example, 2.34 milliliters. So obviously that has to be placed with volume. 2.78 grams per milliliters. So this is a grams per milliliters. Obviously that's not mass. That is actually our density. So if they're giving us our density is equal to mass was not given, volume 2.34 milliliters, and they're telling us to solve for mass. They want us to solve for mass. So what we can do here is we want m by itself, right? So we have to multiply both sides by 2.34 over 1. Like so. All right? This crosses out automatically, and that leaves us with mass by itself. Then, if we put it in 2.34 times 2.78, we should get this number. Again, significant figures. Both of these have 3. 2.34 is 3, 2.78 has 3. That means I only want 3, so it would be 6.50. However, before I round it and say 6.50, I got to make sure, does that make it round up? Of course it does. So our mass is 6.51 grams. All right, let's do example 3. So now we're solving for volume. So it says a sample is 45.4 grams and has a density of 0.87 grams per milliliters. What is the volume? So again, density equals mass divided by volume, and density, grams per milliliter, grams per liter, mass is grams, volume is liter or milliliter. Okay, and always look out what is each one. So 45.4, so they're giving us our mass, so we know that we have grams, we have our mass, has a density, and this is density units, as you can see, grams per milliliter, grams per milliliter. That means that they're not going to give us our volume this time. All right, and that means that that's what we're solving for. Again, we want V by itself. The way to get V by itself, we're going to multiply both sides by V over 1 because we want to get rid of the fraction. Then in this side we have 0.87 times V is equal to 45.4 grams, right? And we want V by itself, so we have to divide by 0.87 to both sides. So 45.4 divided by 0.87. We get this number right here, 52.183. And like I said, we want to make sure that we have the correct number of sig figs. 0.87 has 2 sig figs. 45.4 has 3 sig figs. So technically we just want the 5 and the 2, but before we cut it off, we have to make sure, does the 2 round or stay the same? The 2 stays the same, and it would be 52, and because we want volume, is it liters or milliliters? We always look to see what the density unit was in. The density unit was in milliliters, so this has to be milliliters. Yourselves, why is it that certain objects float in water? Well, the reason has to do with density. Objects that are have less density than the substance that they are floating in or they are in tend to float on top of it. So for example, you will float in water just like your beach ball will float in water, just like, let's say, your lifesaver will float on water. And it all has to do with the fact that these objects have less density than the water that they are normally floating in. So, what is the density of water? Basically, any object that has less than 1 grams per milliliter in density will float in water. So believe it or not, human bodies have very close to 1 gram per milliliter. So this is the reason why we float in water. So if we take a look at this problem, for example, it says if 22.7 grams of sample has a volume of 47.8 milliliters, will it float in water? Well, we have to think about especially what the density is, because we've said that if you are less dense than water, and water's density, the density of water is 1 gram per milliliter. So we always have to check that we are less than 1 grams per milliliter. So what is the density formula? The density formula is density equals mass divided by volume. Remember, mass is grams, volume is liters or milliliters, and density is grams per liters or grams per milliliters. In this case, obviously, it's going to be grams per milliliters because our volume and our mass are in G and ml. So if our mass is grams, that means that 22.7 has to be our mass, grams. 47.8 has to be our milliliters, and we have to divide and see if it's less than 1. So when we compute this, 22.7, divided by 47.8 is equal to 0.47. And remember, significant figures. So we have 3 sig fig here, 3 sig fig here. So we only want 3 significant figures, but 0.474, that is 3, but we need, before we cut that off, does it round up? It does. So it's 0.475 grams per milliliter. All right, and then we have Let's Practice 2, which asks what volume is a sample that has 27.5 grams and has a density of 3.5 grams per milliliter. So we remember that the formula equals density, which is mass divided by volume. This is grams. This is liters or milliliters, and then this is always grams per liters or grams per milliliter. So let's see what we have. We have 27.5 grams. That means that we have either mass or density, but mass only has one unit, which this also has, and density has 2 units, which also has a density, the unit of grams, but it does not have the unit of liters. So that means that the 27.5 is our mass, so this is going to go at the top, and it has a density. So obviously we know that's density because it's telling us that the density is equal to that. So if the density is equal to 3.5 grams per milliliters, that means that our x is our volume. Okay, we don't know our volume, we don't know our x. So if we want to solve for x, we have to multiply, obviously remember, both sides by x over 1 or volume over 1. This variable, guys, it really doesn't matter what you choose. Just make sure you choose a similar thing. Here it crosses out because these are across from each other, so it'd be 27.5 grams is equal to, and then we have 3.5 grams per milliliters times x. And remember, we want this by itself. We want x by itself because we want to get rid of x. So what would we do here? Well, we would divide both sides by 3 divided 3.5, and so we would do 27.5 divided by 3.5, and we would get this big number. But again, we want 2 sig figs. This has 3, this has 2, this has 2. So we want 2 sig figs at the end, so it will be 7.8. But before we cut that off, the 5 makes the 8 round up, so that would be 7.9. Oh, sorry. 7.9, and because this is grams, cross out, so we have milliliters left. So it would be 7.9 milliliters. Now, why milliliters? Because we said volume is either in liters or milliliters. Our units right here is milliliters, ml, so that means this also has to be ml for our volume.